So Hadoop is a framework, and we'll understand in this module like what is Hadoop and what are the different components of Hadoop. And then we'll move on to the first important component, which is called SDFS or Hadoop Distributed File System. So Hadoop is a framework which comprises of multiple, you can say, tools and objects which put together becomes a Hadoop ecosystem. Now these are some of the important components of Hadoop. I'm not saying these are all the components. So there are various components of Hadoop which comprises of entire framework. Out of them, there are some important core components. Without them, without those components, we will not be able to run the Hadoop system at all. If I talk about the core components, they are basically SDFS, MapReduce, and Yarn, which allows you to store and process your data into your system. Hadoop is basically a cluster. We would be defining a cluster in real world where we would be storing the data in multiple nodes. So a cluster is nothing but a group of machines. It is not a single node cluster, but a multiple group of machines working together to store and process the data, because it is impossible to store huge amount of data on a single node. So what is an alternative? The best alternative is to divide your data on multiple nodes. So we'll see that how we are going to store that data on SDFS as a storage layer. How we are going to store that data on a storage layer. So that is for that purpose we have the SDFS. SDFS is primarily the reason to store your data. And how we are going to store the data on SDFS as a flat file system, because it follows a file system just similar to your Linux file system, where we define certain folders in a hierarchical form and we are able to store the files inside those folders. So today we are going to learn about SDFS, how we are going to read and write data on SDFS, how we are going to store our data in SDFS so that we can store any amount of data on our Hadoop clusters. On top of SDFS, we have a mechanism called Yarn. Now Yarn is basically, it's not shown to you in this diagram. So SDFS, this is basically Apache Hadoop ecosystem for 2.x, you can say. The earlier diagram was more related to the older version of Hadoop. So currently we are looking at SDFS as a storage layer. You can see the bottom layer is SDFS, which is basically for to store your data. Then we have another framework called Yarn. Now Yarn is a framework which will allow us to process the data on the data which is available on different nodes, on multiple nodes of SDFS. So as a file, I would not be keeping the entire file on one single server. Since I told you SDFS is a cluster of group of machines, I would not be keeping the entire data of file on one node. Rather, I would be distributing my data on multiple nodes. For example, if I have 1,000 records for a file, I may distribute that 1,000 records in on four servers. In a way, I can keep 250 records each on each data node or on each data server. So I would be distributing my data, and the reason why I'm distributing my data, because so that I can run the process on each data block, on each block of this slice of this data parallelly. Now, if I ask you a simple question, if you want to process 1,000 records sequentially and all the four blocks of report all the four blocks of records like 250 each parallelly, which data will you be able to process much faster? The 4 block data or 1,000 record single block data? Is 4 blocks of data where we can process each block parallelly. So I am dividing my entire data into 4 blocks, and now I'm running the same process on these 4 blocks. A simple analogy would be like, if I give you a 100-man-day job to you, a single person, he will take almost 100 days to finish the job. But if I can divide that work into 10 people, I'm able to finish my work in approximately 10 to 12 days. Same logic is being applied here. We are dividing our data to achieve the processing time much faster, thereby reducing the time taken to process my data. That is why we say in Hadoop we can store any amount of data, and we can reduce the time taken to process the data by distributing our data in such a way that you can process all your data parallelly in multiple blocks. So the parallel mechanism and processing mechanism is handled by Yarn. So Yarn is a distributed processing framework. So whatever query we are writing in different tools like MapReduce, Hive, Pig, all those mechanisms would be taking the help of Yarn to process our data. So Yarn is a facilitator which will process our data and get the job done. Now the queries we have to write in multiple tools. So we can write code in MapReduce in core Java, or we can use Hive as a query tool. We can use Pig as a scripting language. We can write code in multiple other formats like Spark, Storm. There are various tools available in the Hadoop system. We are not limited to any such single mechanism where we can write code only in one language. Gone are the days where we were only dependent on one language, which was Java. Now we have so many tools and options available in Hadoop, whichever language you are comfortable with. For example, if you want to write code in Python, you can easily write code in Python also. Java, Python, any language, you name any coding language, all coding languages are easily applicable in Hadoop. All you have to just write the code, execute the code, and the remaining thing will be managed by the Hadoop framework itself. In Hive, normally it allows you to write the code in SQL. So the data would be in a flat file system, but we can write the query in a structured way. So Hive allows you to write your query in a structured way on unstructured data. Plus, we also have a Pig, which is an important tool which allows you to break your SQL queries into very smaller steps, and you can implement those individual steps of SQL queries in a very very normal in a data flow format, so that you can understand how your data is getting processed. So Pig, Hive, these are important tools to be learned where you can process your data easily. And this also works on your local system plus also on your SDFS. So Pig works in two mode. It allows you to process your data on a local file system also. So you can test your logic on a smaller data sets before you go live on SDFS. They are since Hadoop is open source, Kedarnath. So they are what are they doing? They are integrating Hadoop with their existing software, and they are creating their own packages. So there are multiple packages available where you will find Hadoop as an integrated solution with their other packages of the companies. Like you have different companies like Cloudera, Hortonworks, IBM is another company which they have integrated with their own products, and they are selling as a package, as a more complete a data lake type of a mechanism where you have all the systems integrated and they are communicating to each other. So Hadoop has been used by multiple companies to integrate with their own products, and they are selling that as a complete package. So currently, whatever tool we are going to use, we'll be working on Cloudera package. So SDFS and Yarn are the important layers, and then we'll be working on the different tools available. Hive, Pig, Mahout is a machine learning application. You can use Mahout as a machine learning tool in your system, where you can. It's a different. It's a branch of artificial intelligence. So whatever data we process in Hive and Pig or MapReduce, we can shell that, or we can transfer that, or we can feed that output to Mahout, which is a machine learning application. So whereby we can use some predictive analysis and we can do some other clustering and other technology we can use. So different algorithms are written in Mahout, where thereby we can use and work on that data set. So whatever data we are getting out of big data analytics, we can feed that data to machine learning. Also, we can use the services of R by connecting it to, and we can do some various R functionality easily on the data sets. HBase is one basically a NoSQL database. So in the current session also we'll be learning about HBase as a NoSQL table. NoSQL tables are nothing but is a framework of tables where we keep all the data in one single table. So it allows you to process and do low latency queries much faster compared to your normal database systems. HBase and likewise other NoSQL tables are being used widely in web applications where we need to do a lot of low latency queries. For example, You can take example of Amazon or any other web application where individual buyers or customers or you can say information seekers, they need to get information very quickly from the particular application. So thereby we can use such databases to store and we can extract that information very quickly compared to your normal databases. Apart from HBase, we also have one couple of tools for data ingestion for Scoop and Flume. So I can fetch all my structured data from different databases into my SDFS. For example, if I want to fetch tons of data from Oracle database, I cannot bring it through a FTP or some other mechanism. I can fetch that data easily by the tool called Scoop into my SDFS. And by just connecting to the different databases, I can bring all that data into my SDFS very easily. Flume is also a tool for collecting streaming data and unstructured data into our system, and we can fetch that data very easily into our system, and then we can process the data. So the one thing is clear: whenever I need to work on Hadoop, I need to fetch all that data into SDFS. If I don't bring the data into SDFS, I will not be able to process the data. As simple as it. And another tool is called Zookeeper, which is allows you to coordinate across all the nodes. So we are using a multi-node environment. So all these nodes have to coordinate with each other in order to work your system smoothly. So that is being handled by Zookeeper for coordination services. And to manage your cluster, we have a tool called Ambari. So all your provisioning and managing is done by the Ambari as an admin guy. So Ambari more works like an administrator tool, which allows you to manage. You can add more nodes. You can delete nodes in your system, and you can configure. You can make some changes. So configuration changes can be done in the Ambari tool very easily. So this is a bigger picture of Hadoop system. And Apache is basically is a product, or you can say is a company, different company, Apache Software Foundation. And all these tools are open source. But as I told you, all these companies, distribution companies are taking all these open source products, putting them into one single package and then giving it to you. So there are two ways of installing. Either you install all these packages on your own, or you buy out the entire package from a distribution companies. So currently we are using a package created by Cloudera on our VM system, and we would be having all that into our SDFS. So we can connect to only RDBMSs to fetch data into SDFS and vice versa. So what I can do, I can bring all my structured data into SDFS directly, or I can send my SDFS data to my RDBMS. So both ways it works, import, export, but it is only for databases and nothing else. If you want to fetch data from other files, then you have to use either Flume, or there is one more tool available called Kafka. You can either use Kafka or Flume to fetch the data into your systems. So they all fall into the relational database management system. So they are basically your RDBMS. Uh, they fall under RDBMS platforms. The full form of RDBMS stands for Relational Database Management System. You can say Java language or maybe some other language, but Java is the main primary. You can create classes and you can convert them. You can import those algorithms and you can use them in your system. And Python also you can work on. So you need some external jar files where you can use Python also in your different technologies available. And so within less time, within less amount of time, I can fetch all that data into SDFS by using Scoop. Scoop is a tool to fetch structured data. If you guys are working with RDBMS platforms and if you want to fetch the data into SDFS, then we'll be using the Scoop tool. Flume is for fetching unstructured data, or you can say streaming data. So if you are connecting to some streaming, your log server or a web log server or a Twitter data set, you can connect to the Twitter and you can feed your SDFS without any stoppage. So non-stop data would be feeding to your will be coming to your SDFS. Whereas in Scoop, we are going to bring the fixed amount of data. So whatever data was there, by running that, we are fetching a fixed amount of data into our SDFS. Now, machine learning is not used for automating the process. That tool is called Oozie. Machine learning is a separate mechanism. It's a technology where you can understand your data, and from that data, machine learns and create new models. Based on those models, you are going to predict the future of that behavior of that particular trend, or you can find out some trend or future of that particular model of the new data. For example, if I want to find out the future prices of real estate market of that area, I would be using machine learning for that. If I have about 20-30 years of data, I can easily predict. I can find the trend also, whether the trend is upward or downward or it is going to be stable. So that is a tool called machine learning. So machine learning helps us to understand the data from the old data. So we'll be first feeding the data into Hadoop systems. We'll understand the process of the data, and then we'll feed that data to machine learning algorithms. So by using certain mechanism, we can find out the trend, and we can do some prediction in that. As far as Oozie is concerned, Oozie is a tool where you can automate all your processes. So if you were to first feed your data into SDFS, if you were to feed your data into SDFS first, for example, I have a mechanism where I need to first bring my data into SDFS. Then I need to run a job on that data, first job. Then the first job, I will be feeding the data to another job, second job, and then the third job. So there are two ways of executing the entire all the jobs. Either I do it manually, or either I put all the systems, all the jobs into one single file or a workflow mechanism, and that would be Oozie. So automatically, all your programs will be executed one after the other on the completion of the first, second, and third program, and in a sequential manner. So that is what Oozie does. It allows you to run the entire process one by one in a scheduled way. Plus, it also has a schedule attached to it, so you can schedule your jobs accordingly whenever you want to run the job. So automating the entire process becomes your part of the Oozie workflow. So this is a big picture about Hadoop. All these different tools are available, and that is why Hadoop becomes a very, very powerful mechanism. It has all the tools available where you can store, you can process, you can automate, you can do analysis. Apart from that, there are many other tools like Spark and Storm. We are going to spend some time on Spark also. Spark is another tool, Apache Spark, which allows you to do some in-memory processing. Now, if you try to compare Spark with MapReduce, Spark is much, much faster than MapReduce because it is doing in-memory processing. But the caching part in Spark is that it requires more memory for each data node or each node server. So whatever data we are going to run in Spark, it keeps the entire data in memory. For example, if I were to process 1 terabyte of data, so I would be needing a mechanism to store the entire data in memory for those machines where we are going to run the Spark. But the other advantage we get in Spark that whatever time we are spending in MapReduce, we can cut down that time by 100 part of the second. So like if it is taking 100 minutes in one MapReduce, I can do the entire job in 2 minutes or 3 minutes. So that is the amount of time we gain in MapReduce or in Spark compared to MapReduce. So there are many tools available, Amazon Web Services, where we will be allowing to learn how we can create and manage clusters on Amazon. Ambari is a tool where you will be able to manage the entire network of Hadoop. So Hadoop is a cluster of machines. So basically, you can say it's an admin part of the system. How do you administrate the entire Hadoop? How to add, manage clusters? So that is done in Ambari. Whatever configuration changes you need to make for your file system, we can do that in Ambari. So Ambari is more like an admin tool. It is not a developer tool. And your second query was about how all these are connected to each other. Any other tool from Ambari means what? For managing, currently we have only one tool as Ambari for managing the in Cloudera. So Ambari becomes your main admin tool.
I'm sure you enjoyed learning from this video. Please like the video, and if you have any doubts regarding this video, please comment us in the comment section, and don't forget to subscribe to our channel for more such informative videos. Do look out for other related videos in our playlist. For more information, visit our website now. Keep learning with IntelliPat.